This video tutorial I will explain Apache Kafka. Apache Kafka is a fast, scalable and fault-tolerant messaging system. And Apache Kafka enables communication between producers and consumers using message-based topics. Kafka allows large number of permanent or ad hoc consumers. One of the best features of Kafka is it is highly available and resilient to node failures, and also it supports automatic recovery. And this feature makes Apache Kafka ideal for communication and integration between components of large scale data systems in the real world data systems. What is messaging system? Here you can see messaging system. Here you can see application 1 and application 2. And using messaging system, we can transfer data from one application to another application, so that applications can mainly work on the data without worrying about how to share the data. Distributed messaging is based on the reliable message queuing process, and messages are queued non-synchronously between messaging system and the client applications. And there are two types of messaging patterns are available. The first one is point-to-point messaging system, and the second one is publish-subscribe messaging system. Point-to-point messaging system. Here you can see the queue, here you can see the sender, and here you can see the receiver. Sender or producer sends message to the queue, and receiver or consumer consumes message from the queue and acknowledges back. In the point-to-point messaging system, messages continue to remain in a queue, and more than one consumer can consume message from the queue, but only one consumer can consume a particular message. After the consumer read the message from the queue, the message disappears from that queue. Publish subscribe messaging system. Here you can see the topic, here you can see the publisher, here you can see subscriber 1 and subscriber 2. Both subscriber 1 and subscriber 2 subscribes to the topic. When publisher publishes message to the topic, the same message will be delivered to subscriber 1 as well as subscriber 2. In publish subscribe messaging system, the messages continue to remain in a topic, and unlike point-to-point messaging system, consumers can take more than one topic and consume every message in that topic. And message producers are known as publishers, and Kafka consumers are known as subscribers. History of Apache Kafka. Previously, LinkedIn was facing the issue of low latency ingestion of huge amount of data from the website into Lambda architecture, which could be able to process real-time events. As a solution, Apache Kafka was developed in the year of 2010, and in 2011, Apache Kafka was made public. What is the need of Apache Kafka cluster? As we all know, there is an enormous volume of data used in big data. And for data, there are two main challenges. The first one is how to collect the large volume of data and how to manage the large volume of data. And the second one is how to analyze the collected data. And for dealing with such challenges, we need to have a messaging system. There are many benefits of Apache Kafka that justifies the usage of Apache Kafka. Tracking web activities by storing or sending the events for real-time processes. Alerting and reporting the operational matrix. Transforming data into the standard format. And continuous processing of streaming of data to the topics. And therefore, this technology is giving tough competition to some of the most popular applications like ActiveMQ, RabbitMQ, AWS, etc. because of its wide use. In Kafka architecture, there are 4 core APIs. Here you can see the Kafka cluster, And here you can see the producers which connects to Kafka cluster. And here you can see the consumers which connects to Kafka cluster. And here you can see the connectors which connects to Kafka cluster. And here you can see the stream processors which connect to Kafka cluster for processing the data. Using Kafka Producer API, application can publish a stream of records to one or more Kafka topics. And using Kafka Consumer API, application can subscribe to one or more topics and process the continuous flow of records produced to them. Stream API permits an application to behave as a stream processor, consuming an input stream from one or more topics and generating output stream to one or more output topics, and it efficiently modifying input streams to output streams. Kafka Connector API permits creating and running reusable producers or consumers that enables connection between Kafka topics and the existing applications or data systems. Now we will see Kafka components. Here you can see the Kafka cluster. Kafka cluster can have multiple brokers. Here there are 4 brokers are there, and brokers has topics, and here you can see the producer. Producer creates the message and publish to the topic, and consumer subscribe the topic and consume the message from the topic. And here you can see the Apache Zookeeper which manage the cluster. Now we will see what is Kafka topic. A bunch of messages that belongs to the particular category is known as topic, and data or messages are stored in topics. And in addition, we can replicate the topics, and we can partition the topics. Replicate refers to copies, and partition refers to the division. And topics we can visualize as the logs where Kafka store the messages. However, this ability to replicate topics and partitioning topics is one of the factors that enable Kafka's fault tolerance and scalability. Here you can see the topic which has 3 partitions, and in partition 0, this is the latest message and this is the oldest message. In partition 1, this is the latest message and this is the oldest message. In partition 2, this is the latest message and this is the oldest message. The new messages will be appended at the end of the partition. Here you can see Kafka producer which publish the message to one or more topics, and here you can see Kafka consumer which subscribe to one or more topics and consume messages from one or more topics. Here you can see there are 4 brokers, and these brokers are basically systems that maintain the published data, and a single broker can have 0 or more partitions per topic. Here you can see Apache Zookeeper. With the help of Zookeeper, Kafka provides the brokers with metadata regarding the processes running in the system and grants health checking and broker leadership election. Now we will see log anatomy. We view log as a partitions. Here you can see the log, and here you can see the data source. Data source writes data to the log at the end, and here you can see the consumer which read data from offset 5, and here you can see the consumer which read data from offset 7. Basically, log is being written by the data source and read by consumers at different offsets. Now we will see data log. By Kafka, messages are written for a considerable amount of time. Also, consumers can read as per their convenience. And however, if Kafka is configured to keep messages for 24 hours and consumer is down for greater than 24 hours, then consumer will lose all the messages. and messages can be read from the last known offset. And if the downtime on part of consumer is just 60 minutes, and Kafka doesn't keep track on what consumers are reading from the topic. Now we will see partition in Kafka. Here you can see broker 0, it has 3 partitions. Here you can see broker 1, it has 3 partitions. Here you can see broker 2, it has 3 partitions. And the partition in red color is a leader, and the partition in blue color is a replica. And here you can see the producer, whatever message written to the partition 0, which is the leader, which will be replicated to partition 0 of broker 1 and partition 0 of broker 2. In each Kafka broker, there are partitions. Each partition can be either a leader or a replica of your topic. And leader is responsible for all writes and reads to a topic. And leader is also responsible for updating new data to the replicas. And the replica will take over as a new leader if somehow the leader is fails. Now we will see Kafka use cases. Messaging. Kafka is best substitute for traditional message brokers because Kafka has better throughput, replication, and it support fault tolerance, and it has built-in partitioning, which make it is better solution for large-scale message processing applications. Metrics. Kafka is mostly utilized for operational monitoring data. It includes aggregating statistics from distributed applications to generate centralized feeds of operational data. Event sourcing. Kafka is a great backend for applications of event sourcing since it supports very large stored log data. You can get the Java source code link from the description section of the video. To see the description in mobile, click on this icon and it will expand like this. Then click on this more button to see the description. And in the description, you can see the links. And click on these links to get the Java source code.